Hello, this is Karima Mosi, Resource Specialist for the Charter School of San Diego. In this video, I will provide an overview of Lesson 17 of Earth Science 2, the Ocean Currents Lab. I will introduce you to the purpose of the lab, the materials you will need to complete the lab, and I will outline the procedures you will need to follow. Let's start with the purpose. In Chapter 15 of your Earth Science textbook, you read about the chemical and physical properties of saltwater, as well as what causes ocean currents. In the Ocean Currents Lab, you'll explore in more detail about how factors like temperature, density, and salinity affect the movement of ocean water. During the lab, you'll answer the following question: how does salinity and temperature create ocean currents? So right now you're probably thinking, the ocean is so big and dangerous. How can I possibly answer that question? I don't have a wetsuit or a boat. I don't even know how to swim. Don't worry. That's the beauty of science. In this clip from Bill Nye's Ocean Currents video, you will see how it is possible to mimic characteristics of ocean water in the comfort and safety of a laboratory.
Here we have some colored water, and here's some salt. Now suppose we dissolve these equal amounts of salt in this water. Which one is going to taste salty? I don't know. Well, let's try it. Well, that's easy. This one's going to taste saltier because it has the same amount of salt dissolved in less water. Now let's say we were out in the middle of the ocean and the sun is beating down. What's going to happen? Well, some of the seawater is going to evaporate into the air and the salt is going to stay there. It's just like having the same amount of salt dissolved in less water. Now the more salt in the water, the heavier it is. So it sinks. See? Now the currents set up by warm and salty water sinking and rising in the ocean are called thermohaline currents. Now thermo, that means heat. Haline, that means salt. Thermohaline currents make huge masses of seawater flow in huge currents all over the world. It's salt. It's thermohaline. It's salty.
Don't drink that, Bill.
It is salty.
Oh, dear.
See there? No scuba diving license required. All you need is curiosity and the following materials. First, you'll watch the entire 26-minute Bill Nye Ocean Currents video. It provides an entertaining overview of the topic. Ask your classroom teacher for a copy. You'll need salt, food coloring, and a spoon. The food coloring is important because you'll use it to color your water samples so that you can see them move more easily. You'll need a measuring cup and 2 pipettes. A glass measuring cup is important because you'll need it to heat your water in the microwave. You'll need 2 test tubes and a test tube holder, 1 1,000 milliliter beaker, and 4 250 milliliter beakers. You'll need 4 colored pencils. Notice the pencils are the same colors as the food coloring. You'll need these pencils to record your data. To get started, first you'll use your textbook to define the following key vocabulary terms: convection, density, salinity, temperature, and thermocline. Be sure to write your definitions neatly on a piece of paper. You will turn the definitions into your classroom teacher. Next, you'll watch the Ocean Currents video. We'll let Bill Nye and his cast get wet and dirty so we don't have to. Be sure to take notes as you watch the video. Now it's time for the hands-on portion of the lab. The experiment has 2 parts. In part 1, you'll be comparing how temperature affects ocean currents. You'll compare the movement of near boiling hot water to ice cold water. You'll be asking yourself questions like, which temperature will move more quickly? Which will sink? Which will flow closer to the surface? Be sure to record your observation data on the form provided in your lesson guide. In Part 2, you'll be observing how density affects ocean currents. You will take two solutions of water. One solution will have a high salt density, the other will have a low salt density. Which solution will stay closer to the surface of your ocean? Which solution will flow to the bottom of a test tube? Once again, be sure to record your observation data in the form provided in your lesson guide. After you've completed both experiments, you will analyze your data. There are 5 analysis questions for you to answer in your lesson guide. In your responses, you'll be expected to use complete sentences to synthesize your information that you've learned from the video, Chapter 15 of your textbook, your lab observations, and your vocabulary review. After your careful analysis, you'll be ready to infer an answer to our research question. How does salinity and temperature create ocean currents? This concludes the introduction to Earth Science 2, Lesson 17, Ocean Currents Lab. If you have questions about the information described in this video, please see your classroom teacher. Thank you for watching.